Okay, guys, physics 1.6 to 1.8 quiz. Honestly, this one's way easier than the other one. Like, if you just focus with me, you probably don't even have to do it yourself. Okay. Which of the following are characteristics of good home insulation? Should be effective, should be complete, and should be cheap. This question, there's not much explaining. It's just common sense. You don't need to. There's, yeah, just common sense. Which of the following are ingredients for insulation? So here the answers are walls with cavity insulation, loft insulation, and porous sponge floor covering, single glazing windows, and many leaks. No. Okay, these three answers they all rely on the same thing. Just guys, look, air is the best insulator, but air, like convection happens in it, which transfers heat. So when you have small packets of air, like let's say double glazing glass, you have two glasses very close to each other, convection can't happen because it needs space. Like the air goes like this, hot is down, cold is up. It goes to the hot and it like moves like this. Yeah, this is convection. But with double glazing glass, for example, there's no space. Like the friction on the glass and stuff with the air, it's not gonna let convection happen. So for all these three, they all rely that there's small like pockets of air. Porous sponge, it's like a sponge with like small gaps of air in it. Walls with cavity insulation, like it's walls with like a cavity in them, same as the double glazing glass. Like there's like too much friction for convection to happen at a rate that would transfer heat properly. And loft also, it's like a material. It's like this kind of. It's a material also with small pockets of air. During convection, one part of a fluid sample is heated, it becomes less dense, so it tends to float upwards. Okay, guys, in convection, let me just explain what it is. You have hot at the bottom, like you're heating it from the bottom, for example, and cold at the top. Okay, so hot is less dense than cold, so it goes up. It mixes with the other temperatures while it's going up, and then now it's cold because it mixed with everything, so it goes down. So this is basically the convection current. It goes from hot to cold and it just goes like this. Okay. So during convection, one part of a fluid, it only works with gases and liquids. With solids, obviously, you can't have a current. A sample is heated, becomes less dense, so it tends to float upwards. Which of the following statements are true about heat transfer by radiation? Radiation from hot bodies can travel through empty space. Radiation can travel through empty space, yes. Only hot bodies can radiate energy. No, hot bodies and cold bodies both radiate energy. Okay? But cold bodies, they just radiate less energy. The energy lost by a body is emitted in portions called quanta. Yes, that's what they're called. Radiation can be defined as the flow of heat from one place to another by means of electromagnetic waves. Yes. Okay, in order, let's just read the question. The table below provides a linear expansion coefficients of several metals. The combinations of these metals are used to make bimetallic strip thermometers. Okay, in order to make a thermometer with the longest bend. Okay, guys, let me explain this. So here, let's say you have two metals. Okay, I'll use the black color for one metal. And then you have the blue color for another metal. At normal temperatures, they're the same. But let's say black has a higher coefficient of thermal linear expansion. Let's say black is 10 and blue is 5, for example. So So black, it would bend more, it would grow more, like it doesn't, the coefficient of thermal linear expansion doesn't cause it to bend, it just causes it to grow. So let's say they're attached and black grows, but it's gonna bend. Why? Because also the blue is growing but less. Like see the added area on the blue now it's less, and the black it's more, but they need to be they're attached, so it's gonna curve to the blue. It also contracts faster with the higher coefficient. Okay. So in order to make the thermometer with the largest bend for a given increase in temperature, we need to glue the one with the highest coefficient and the one with the least coefficient together. So it's gonna be aluminum, which is 24, and iron. So aluminum strip and the iron strip. Strip 1, okay, another bimetallic strip is made from the materials listed in the table. The bimetallic strip is heated and bends as shown. So strip 1 bends less than strip 2, which means strip 2 has a higher coefficient. And here they said strip 1 is made of aluminum, is made of silver. So strip 2 has to have a higher coefficient, so it's going to be aluminum. An aluminum rod whose length at 0 degrees is 1200 centimeters is heated to the temperature of 80 degrees Celsius. The coefficient of linear expansion of aluminum is 24 times 10 to the power of negative 6. Okay, so there's a formula for this one. Don't worry guys, in this whole quiz there's only 2 formulas. This is one of them. It's delta L. The change in length is equal to the initial length times the coefficient times the change in temperature in Kelvin. But the change in temperature, since degrees Celsius and Kelvin, like 1 degree Celsius is also 1 Kelvin. So if you do T final minus T initial, like let's say you have 180 minus 100, you're gonna get the same answer as 80 minus 0. Like the difference is gonna be the same. So here delta L, we don't know it. The initial length is 1200. The coefficient is 24 times 10 to the negative 6. 24 times 10 to the power of negative 6 times delta T is 80 minus 0, T final minus T initial, so times 80. You put it on your calculator. 1200 times 24 times 10 to the power of negative 6 times 80. You get 2.304. But that's not the answer. This is delta L. They want the final length. So 2.304, the L, is equal to, let's see, T final, which is X, minus T initial, which is 1200. So if you put this on your calc, you're gonna get X equals 1202.304, and they want it to the nearest integer. The answer is just going to be 1202. Okay, the coefficient of surface expansion of copper at 20 degrees. Okay, look. This is linear, yeah? So it's like a line. It's a one-dimensional line, and it's expanding by this coefficient. If it was a two-dimensional shape, then you would just multiply the coefficient by 2. Let's say it's a cube, it's a three-dimensional shape. Then the volume, which is like the length cubed, would be you multiply by 3. So this is the coefficient of linear expansion would be this, and this would be 2 times the coefficient, and this would be 3 times the coefficient. Okay? So 17, it's a surface area, so it's the linear expansion times 2. So 17 times 2 is 34. The coefficient of volume expansion, it would be the cube, the linear expansion times 3. So it's going to be 51. Guys, which of the following answers to classify objects in the table as good or poor conductors? Liquid mercury, it's a metal, which makes it a good conductor. And guys, the reason metals are good conductors is because they have free electrons. And the electrons, they help conduct the electricity because they're moving around a lot. So all the metals are good conductors. Fiberglass, it's actually a good insulator. It's a very bad conductor, so poor conductor. And water vapor, guys, gases in general, they're bad conductors. Usually gases are bad conductors. Okay. Contains free electrons, I just explained it, good conductor. Contains only combined electrons, so the opposite, so it's going to be poor conductor. Gases are poor conductor. Contains packets of air, poor conductor, because gas. And also air is a very bad conductor of electricity and heat. Is a metal good conductor, because it has free electrons. The use of double glazing window panes reduces the amount of heat escaping the house through convection. I explained it in the first question. When you have two glasses, it prevents convection, so it reduces the amount of heat escaping. It like insulates it, because the heat doesn't, like the current, it doesn't have space to happen. Like, it's confined, it's friction and stuff. Convection. A room filled with air is heated by a radiator. So you might think it's radiation, but no, let's say this is the radiator, yeah? So this is hot. This would be hot around the radiator. And the other parts of the room, by comparison, are cold. So the hot air would go to be cooled, and it would come down and it would be hot. So it would rotate like this, like the convection current. So it's going to be convection. Earth is heated by the sun's rays. So between Earth and the sun, there's a vacuum, and the only one of those that can travel through a vacuum is radiation. Also, the sun's rays are radiation. Okay. A cooking pan is heated by an electric heater. This one's conduction because they're in contact. Radiation can travel through gas, liquid, or air. Conduction can travel through also gas, liquid, or air. Gas, liquid, air. Convection can only happen in fluids because you can't have a current in solids. Okay, a bimetallic strip is made of a copper strip and aluminum strip, both of length 62.8 and of thickness 0.1 millimeters. The coefficient of thermal linear expansion of copper is 17 times 10 to the power of negative 6, and that of aluminum is 24 times 10 to the power of negative 6. So guys, see, there's a lot of numbers, but this question is actually really simple. Fill in the blanks to complete the diagram below to show the location of aluminum and copper. So aluminum has a higher uh, coefficient of linear expansion, so it's gonna be longer at the end. Now, guys, like using your brain, yani common sense, which one is longer, the one outside or the one inside? Obviously, it's the one outside, so the one outside is aluminum, aluminum, and the one inside is copper. Okay. It is dangerous to swim in water whose temperature is below 20 degrees Celsius. For divers to safely swim at low temperature, a dry suit is necessary. The two main processes of which the human body loses heat when in the water are convection, because you're in a fluid and there's convection happening. Convection, and conduction, because the water is in contact with your skin. Okay, a person loses much less heat in air than in water at 10 degrees because the coefficient of linear expansion of air is 0.72 kilojoules per kilogram times Kelvin, is much lower than that of water, 42,000 kilojoules per kilogram times Kelvin. Okay, the coefficient of linear expansion. Oh wait, no. Wait, my bad. Specific heat capacity. What coefficient? Specific heat capacity. The thing is expanding. I don't know why I said that. Okay. Also, what's this? B. Okay. This one, I don't know why the specific heat capacity makes it like transfer heat less. I'm not sure of that, but also water is a better conductor than air, so I thought like it would conduct the heat out of your body. Also, that's why when you touch a metal, it feels cold, because it's conducting the heat out of you, like it's taking heat from you, because it's such a good conductor. So I thought water is also like a better conductor than air, so it would take it, but I don't understand the specific heat capacity. A dry suit is made of neoprene, a kind of rubber. Would you expect the neoprene material to have free electrons? No, because you don't want it to conduct the heat out of your body. You want it to be an insulator. Free electrons help in conduction, because it should be a heat insulator. The predominant heat transfer process which increases the temperature of air above the gas burner. Okay guys, this one, you have the hot air. You have the hot air in the burner. Okay, this is the burner. You have hot air in it. Okay, and the hot air, it goes up with the convection current and pushes on the walls of the hot air balloon. It pushes it up. So this is caused by convection. Convection. Okay. In which of the following media can the heat transfer process identified in part A occur? In liquids and gases. Fluids only. And you can't have a current in a vacuum. Nothing's moving, there's nothing there. An adult male at rest must consume 6.7 megajoules of energy per day to maintain a constant body temperature. As the food is processed by the body, the cells in the body generate energy. This energy is transferred throughout the body. The heart pumps the warm body to all its extremities. Okay guys, this question, look, so there's natural convection and forced convection. Natural convection is when you have hot and cold and it's going by itself, the convection current. Forced convection is when the hot is like being pushed. So let's say also, or the cold is being pushed, or like let's say like this, in this case the heart is pumping the blood, it's pushing the blood, so that's forced convection. Also, let's say like you're eating something, for example, it's hot, so you blow on it. That's forced convection. You're blowing, so you're pushing the cold air onto it to remove the hot air. That's forced convection. Forced convection, the process by which a person loses most heat to the surrounding air. So you lose the heat by natural convection because obviously no one's blowing on you. Or if it was windy though, it would be, if it was like strong winds, that's forced convection because the winds are forcing the convection. The predominant process that transfers heat from the UFO heater to a person standing next to it. Okay guys, because it's a person standing next to it, it's radiation. Because convection currents, they don't travel to the side. They don't travel to the side. They travel like up and then they cool and then they go down. That's how they travel. They only travel like this. They don't travel to the side, down, left. No, they only travel like this. So if you're beside it, then it would be radiation because also it's emitting, it says in the question, emitting the electromagnetic waves. By the kinetic molecular theory, the heat transferred by conduction occurs when faster moving molecules in the hotter parts of matter collide with the slower moving molecules in the colder parts of matter, thus passing onto them part of their kinetic energy. Okay guys, remember in the quiz before it, 1.1 to 1.5, there was a question where like you had to use the kinetic molecular theory. Basically, kinetic energy is directly proportional to temperature. So let's say, which means a hot particle has the exact same meaning as a fast particle. It's the same thing. Okay, so let's say a fast particle, okay, let's say this is a fast particle, yeah, it's moving fast. It hits the cold particle, okay? So now the cold particle, it takes some of that energy, so it's also moving fast. It's moving a bit faster, okay? So faster moving particles, which are the hotter ones, or in the hotter parts of matter, collide with the slower moving ones in the colder parts of matter, so they transfer some of their kinetic energy, which is the same as saying that they make them hotter. Okay. What is one action that can be done to try to fit the solid sphere? So this is solid sphere, you're trying to fit it through a hole. So if you cool it, it would contract, so it would fit through the hole. Which statement best explains your answer in part A? Cooling shrinks the sphere. The picture below shows an experiment used to compare different materials. 4 matches are waxed on one end of 4 different metal rods while a Bunsen burner heats the other end. How can you tell which metal is the best thermal conductor? Okay guys, obviously the best thermal conductor is the one that's gonna get heat the fastest to the matches. So if you're moving heat faster, that means you're a better conductor. The one lights the match. I mean, if you're transferring the heat, no, because you need a flame to light the match. Changes color, has nothing to do with color. Loses its match first, because I think I think they would like, the heat would cause them to fall off, because it would cause the thing sticking them to fall off. Okay. Which surface is the better absorber of heat? Okay guys, look. You know how white, yeah, you have a white is basically, it reflects all light coming to it, and black, it doesn't reflect any light. That's why you see it as black, and that's why you see white as white. Green, it absorbs everything, but it reflects green. So the color you see is the color it reflects, and light is all the colors, and black is not. Okay. So if it's taking the heat, the electromagnetic waves, okay, it's taking them and it's releasing them back. It's like reflecting them. And this one, it's taking them and it just keeps them. So which one do you think would heat up faster? The one that's taking them and keeping them, or the one that's taking it and reflecting it back? Obviously, the one taking them and keeping them. So the black one. Which surface better reflector of heat? The white surface. Which surface is the better emitter of heat? So emitter of heat, it's black surface. This one, I don't know. I thought it would be white because it reflects it, but the answer is black, and I'm not sure why. Maybe because it takes it, so it gets hotter, and then it, like when it's hotter, it emits more. Maybe, I don't know. I'm not sure of this one, but yeah. Okay, guys, and I told you at the start there were two formulas. This is the other one. It's E equals HF. So E is energy in joules. H is Planck's constant, which is this always. Planck constant. Planck constant. And the frequency, it's the hertz. So H times F gives you the energy, and they want the energy. So you just multiply 6.6 times 10 to the power of negative 34 times 1.2 times 10 to the power of 15. You get wait, I don't know why. Just give me a second, guys. Six point six. Yeah, you get 7.92 times 10 to the power of negative 19. 7.92, so 7.9 times 10 to the power of negative 19. You guys, this quiz was light, to be honest. Like, quick. Didn't worry about it too much. But yeah, okay, guys.